Hey Jonathan and Maxim, I really need your guys' help. I have a Kinetics exam in a few hours and need a quick refresher on the unit.
I remember the beginning of the kinetics unit very well. Let's start. For this reaction, these are the rate expressions. Each expression is equal to the rate of the reaction. We can see how the coefficients from the reaction are used to create these expressions. The typical units for the rate of a reaction are molarity per seconds. Let's try a practice problem, Cody.
Let me give it a try. The question tells us how much a concentration of I- decreases in 10 seconds. To find the average rate of the reaction, I set up the rate expression using the coefficients. Then, I plug in the given value to find the average rate of the reaction.
Great job, Cody. Now let's talk about rate laws. A rate law looks like this. K is the rate constant, A, B are the reactants, and X, Y represent the orders, which show how important a reactant is to the rate of a reaction. We can find order by using some experimental data. Notice that when the concentration of A is doubled, the rate of the reaction is also doubled. This is first order because the concentration of A and the rate are proportional. A zero order is when the reactant doesn't affect the rate, and second order is when the scale factor of the rate is squared when compared to the concentration of A. We can find the rate constant by using the experimental data. We simply plug in the known values into our rate law and solve for K. To find the units for the rate constant, we start off by writing our rate law. We know that the units for the rate of a reaction are molarity per second, and the units for concentration are molarity. When isolating K, we can find the correct units.
I'm very good at the end of the kinetics unit. Let me cover this part. Cody, prepare to be a kinetics master.
Before you saw Jonathan, let me try an integrated rate laws question. The question gives us the order, rate constant, and initial concentration. We need to find the concentration after some time. We simply use the first order equation and do some math to find our answer.
Nice one, Cody. This is called a reaction mechanism. The reaction labeled slow is called the rate determining step. It allows us to find the rate law by using the coefficients of the reactants as the orders. A catalyst is consumed and then produced as shown by the reaction mechanism. On the other hand, an intermediate is produced and then consumed. A reaction is unimolecular if the sum of the coefficients is 1, a reaction is bimolecular if the sum is 2, and finally, a reaction is termolecular if the sum is 3.
Thank you guys so much for helping me. I am very confident that I will do great on my Connect exam now.